All right, we are going to look at permutations and combinations today. These can be a little bit tricky for people, so hopefully that it will be okay for you. But a permutation is an ordered arrangement of objects. It's when you grab a group of objects, and then once they're grabbed, you need to put them in a specific order, whether that's a specific seating chart, a specific spot on the shelf, a specific job to do, a specific prize to get, whatever. But you're going to not only choose them, but once they're chosen, you are going to do something with them. Okay, so it's a little more specific. A permutation is more specific, but it's an ordered arrangement of objects. Order matters, okay? Combination is an unordered arrangement of objects. You just grab a group of people or objects, and they're all going to do the same thing. They don't need to sit in a specific spot or have a specific job to do or get a specific prize. Everybody gets treated the same once they're chosen. Everybody does the same exact thing, or every object does the same exact thing once it's chosen, okay? So that is the difference. You will see some notation there for permutation and combination. This is what this means. P stands for permutation. N stands for the total number of objects that you have to choose from. And K is the number of objects that you are choosing. So like if this was 9 and 5, that means there was 9 objects chosen, or 9 objects total, I mean. And you will choose 5 of those 9 objects, okay? Same thing with combination. The C means it's a combination. N is the total number. K is how many get chosen, okay? If you remember that a little exclamation point does not mean I'm really excited about that. It means factorial. And remember that factorial is like 7 times 9 times 8, or 7 times 6 times 5 times 5, blah, blah, blah. 7 times 6 times 5 times 4 times 3 times 2 times 1 is factorial, okay? So, that's that, and I'll show you some ways to simplify this when we do this. You can do permutations on your calculator by using the NPR button, and I will show you how to do that too, and then combinations as well. Okay, so we will simplify some of these, and we will go from there. Alright, first of all, do these situations require permutations or combinations? So in the first example, your teacher tells you to answer 4 of 6 questions on an essay test. And wants to know how many ways you can do that. And so, again, your teacher does not care when you hand your test in which question you answered first, second, third, fourth, whatever. They don't care. What your teacher cares about is which 4 questions you answered. And so it's a little less specific. You're just picking 4 questions. Order doesn't matter. And so this would be a combination. I'm going to put C for combination. Okay. Choose 5 of 8 people to sit in assigned seats. So that means, you know, one person has to sit, let's say, on the far left, the next person next to them, but you have a specific spot to sit. And when you choose those 5 people and then put them in a specific spot to sit, you're doing a permutation. Okay, I'm going to have these 2 on the screen at the same time so that you can read the difference. The first one of them, you're choosing 4 of 20 people to serve on a subcommittee. Again, it doesn't say anything about a specific job. It just says you need 4 people to serve on a subcommittee. The next one says that you need 4 of 20 people to serve as the officers of the subcommittee. So that means you need to have a president, a vice president, a secretary, and a treasurer. So now those people are not only being chosen, but they're given a specific job to do once they are chosen. And so the difference is, this is everybody's doing the same job. Pick the 4, it doesn't matter in what order, combination. This one, you're picking the 4 people and then assigning them a job to do once they're chosen. And so that one would be a permutation. Okay. Here, 3 people in a class of 25 are going to receive a Hershey's Kiss. The difference between that one and the next one is that, so the first one you're going to choose 3 people and they're all going to be treated the same. They're all going to get a Hershey's Kiss, 3 of those 25 people. The next one, you're going to choose 3 people, but they're going to get different prizes. So, the top one is a, excuse me, a combination. Everybody's getting treated the same. The next one, you're going to choose the 3 people. It's a permutation, but then once they're chosen, you have to decide, is that first person chosen going to receive a kiss, a Snickers, or a Kit Kat? Is the second person chosen going to receive which prize? Whatever. And so that's why it is a permutation, because they are different prizes. If they're all the same prize, it's a combination. If they're different prizes, it's a permutation. Alright, so now Susie Q here has 7 different scents of lotion that she is going to place on a shelf. So I have 7 spots that I need to fill. I just kind of want to show you how this factorial business comes about. And this is what happens. In this spot right here, she has 7 choices to fill her shelf with. 7 choices of lotion, and then 6, and then 5, and then 4, and then 3, and then 2, and then 1. Okay? Order matters here because they are sitting on a shelf in a specific spot. So you're choosing 7 things and then putting them in a specific spot. If we were to do 7 times 6 times 5 times 4 times 3 times 2 times 1, that is 7 factorial. So that's one way we could do this problem. Or we could do this. We have 7 objects. It's a permutation because order matters, and we're choosing to place all 7 of them. And I'm going to show you how to do that on your calculator. Okay, so to do that on your calculator, what you will do is you're going to go to your main screen. You're going to put the 7 in first, the total in first, and then you'll do math, and then over to PRB, and then you want number 2 for permutation, and PR is permutation, and then 7. So 7 objects, you're permutating them, and you're choosing all 7. And so when you do that, you should get 5,040 when you do it that way. And by the way, yeah, 5,040. Okay. I'm going to show you this on your calculator too. Maybe you saw it when I did the other one. But if I were to do 7 factorial, then I would do 7. And then you could multiply 7 times 6 times 5. That's too long though. You could do 7. Math again. Over to probability. And you can see the factorial button is number 4. So there's 7 factorial. And I'll still get 5,040. Oops, I forgot my 0 right here. Okay, or if you want to think about it in factorial notation way, and this is going to come up in accelerated math and in other places in your math career, so it's kind of important that you know this as well. But the other way you could do it is this. You're going to do a permutation of 7 objects, and you will choose 7. And so if you follow our little formula up there, you will have 7 factorial on the top. That's this number. And then on the bottom, you'll have 7 minus this number, which also happens to be 7, factorial. And so you have 7 factorial over 1 factorial. Well, 1 factorial is just 1, and so 7 factorial over 1 is just 7 factorial. Either way you do that, again, you're going to get 5,040. Okay? On to the next one. This time, if you're only placing 4 of the 7 objects. So now, if you think about this, you have 4 spots on the shelf, and you have 7 choices, 5 or 6 choices. Sorry, I can't even count backwards. 5 choices, 4 choices. So you can multiply that and figure that out. That's one way to do it. Or you can do a 7p4 on your calculator. 7 objects, order matters, so it's a permutation. You'll choose 4 objects to place. Or you could do a permutation of 7 objects and choose 4. And if you follow our little formula, that means that you will have 7 factorial over 7 minus 4 factorial, which is 7 factorial over 3 factorial. Okay? So either way you want to do that, it does not matter. Either way you want to do that, you are going to get 840. And again, you know where your factorial buttons are on your calculator, and you know where the permutation button is, hopefully. All right, and then part C, she wants raspberry and vanilla on either end. So this has to be either raspberry or vanilla right here. I have 2 choices. Whichever one goes here, the other one has to go here. So that's a guarantee. And then notice you've used 2 cents. You've used raspberry and vanilla, and so you have 5 choices left. And those 5 choices will go something like this. This much right here is 5 factorial, and then times 2 times 1, or 2 factorial if you want to say that. And when you do that, you will get 240. All right, the next one. Your boss has told you that you have to work 3 days next week. How many ways can this be done? Your boss didn't tell you to make a first choice, second choice, third choice. Your boss just said pick 3 days. You're going to work all 3 days. Hours are the same. No different job any of those 3 days. So this is a combination. And so you can either go 7, C3, 7 combination of 3, order doesn't matter. Or you can go a combination of 7, 3 like this. And if you're going to follow our little formula then, that means that you will have 7 factorial over 7 minus 3 factorial times 3 factorial, or 7 factorial over 4 factorial times 3 factorial. And by the way, on the bottom, you can't go 4 times 3 and make that be 12 factorial. That doesn't work. You have to take 4 factorial times 3 factorial. Either way you do that, you will get 35. Okay? The next one, 4 of 7 items from column A, 3 of 8 from column B, 2 of 5 from column C. And again, I didn't say it has to be in a specific order or it has to have a specific job or it's going to get a specific prize or anything. So these are just C's. And again, you'll go like this. 7C4, 8 items, choose 3, 5 items, choose 2. Order does not matter. What people get wrong on this kind of problem is what symbol goes in between. And I purposely did not put a word in right here. But if you were to think about what word you would insert right here, I hope you can figure out that you would insert the word and. It's assuming that you're going to do items from A and B and C. And in probability means to multiply. And a lot of times people get this wrong because they will add. Okay? So you can do this, or you can follow all the fancy formulas too. I'm going to just leave it at this because I think most of you will do that. And you will have 19,600 choices. All right, now you need to arrange the letters in the word almond. So basically this could be a L, M, N, a O, a N, or a D. So you have 6 spots to fill still. And apparently I can't count. Again, this could be a L, M, O, N, or a D. Okay, so you have 6 choices, 5 choices, 4, 3, 2, and 1. Okay, so if you need to think about it that way, go for it. This is the same as 6 factorial. It's the same as 6p6. Order matters. It matters whether the A is the first letter in there or the third letter or the whatever letter. Or you could go again like this. And this is 6 factorial over 6 minus 6 factorial, or 6 factorial over 0 factorial. And I know it seems like you can't divide by 0, but guess what? 0 factorial is 1, which seems kind of weird, but it is. Either way you do that, when you punch that into your calculator, however you choose to do it, you should get 720. Okay? The next one's pretty similar, except for the problem is you have repeated letters. So you have R, you have T, and you have O that all repeat. And I have 2 R's, and I have 2 T's, and I have 2 O's. So what you need to do is on the top, you're going to look at the total. I have 12 letters in the word trigonometry, so 12 factorial on the top. On the bottom, you need to take out the repeats. So because I have 2 R's, I will do 2 factorial. And because I have 2 T's, I will do 2 factorial. And because I have 2 O's, I will do 2 factorial. And I know you're going to want to go to your calculator and punch all these in. Now just think about it though. 2 factorial is 2 times 1, and 2 times 1 is 2. So you have basically on the bottom 2 times 2 times 2, which is 8. So don't get tripped up by all these symbols. Do a little math in your head once in a while because it's going to go much faster. When you type this in, you'll have 59,875,200. All right, 5 poker hand. You're going to be dealt, there's 52 cards and you're going to be given 5 of them. And the question is, does order matter? So like in your hand, let's say you have ace, jack, queen, king, and somebody else is holding their hands, and I know this can't happen in the same deck of cards, but let's say somebody else in their thing has a jack, and let's say these are all hearts, okay? They're holding theirs like this: jack, queen, ace, king of hearts. This is how it looks in their hand as you're overlooking their shoulder. The question is, would you consider this and this to be the same hand? Their order is different, but would you consider them to be the same hand? And I think you would. And so basically what we're saying is, in a hand, order doesn't matter, okay? And because order doesn't matter, then this is a C. So this is a combination. Or, again, you could do a combination of 52 and choose 5, which would be 52 factorial over 52 minus 5 factorial times 5 factorial. Okay? Either way you do that, When you punch that into your calculator, you should get 2,598,960 possible ways to have 5 cards from a deck, which is an awful lot. Now you know why people don't win very often. All right, on to the debate team here. This time you have, let's see, 9 people. In the first thing, it doesn't matter who sits next to who. Order still matters. I'm still putting them in assigned seats, but I don't care if a historian sits next to a political scientist or whatever. So I have 9 seats. I need to fill all 9 of them. So I will do 9p9. Or again, I could do permutation of 9, choose 9, which would be 9 factorial over 9 minus 9 factorial. Again, either way you do that, you should get 362,880 ways to seat those people. In the next one, I have to have a historian seated on either end, and the rest of it doesn't matter. So this has to be a historian. I have 3 choices for that then. This has to be a historian, so now I have 2 choices. And now I have 7 spots that I haven't filled. So those 7 spots will go something like this. You can see that this much is 7 factorial, and then times 3 times 2. Or you could do 3 factorial because 3 times 2 times 1 is the same thing. Either way, you're going to get 30,240. Okay, and then this one, those in the same field must sit together. So, let's say that these are the historians. So you have 3 choices, 2 choices, 1 choice. These are the economists, so 4, 3, 2, 1. And these are the political scientists. So we can see that this is 3 factorial, and this is 4 factorial, and this is 2 factorial. The problem is, does it have to be that the historians are first, and the economists are second, and the political scientists are third? And it doesn't. So you need to also have a 3 factorial in here, because you can mix up those 3 groups, okay? Those 3 groups can be switched around as well. And so that's why you have to have the 3 factorial in there. So 1,728 ways. All right, and last problem here. We have a license plate, 3 numbers, then 3 letters. How many different plates are possible if repetition is okay? So in this spot, I actually have 10 choices for a number because it could be a 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So I have 10 choices. The next number can repeat, so I still have 10 choices. Again, it repeats. And then the next one is a letter, so I have 26 choices. Repeats are okay, so those 2 are also 26. So 17,576,000 when you multiply all of that out. If repetition is not okay, then you have 10 choices for the first number, 9 choices for the second number, 8 choices for the third number, and then we go to letters, 26, 25, 24, so 11,232,000. Okay, and on to the last one. The first letter must be a vowel, the first number cannot be a 0, and no repeats. Alright, so this first number can be any number but 0, so I have 9 choices. The second number now, I can add 0 back, but it can't be whatever number I used first. So it can be 0, 1, 2, 3, 4, whatever, any number except for the one I already used. So I still have 9 choices, and then I have used 2 of them, so now I have 8 choices. The first letter has to be a vowel. We're sticking with the traditional definition of a vowel, so A, E, I, O, and U, so there's 5 choices. The next letter can be any letter except for the one I've already used. So there's 26 letters, but I used 1, so now I only have 25. And then the next one, of course, would be 24 if repeats are not okay. And when you do that, 1,944,000 possibilities. Okay, so that should do it for this lesson of permutations and combinations.